Okay, so in this lesson, we're going to simplify radicals, and this will be part one. As a review, let's discuss how to or what the square root of 16 means. Okay, so the square root of 16, remember, is going to be 4 because, and this is important, because 4 squared is 16. So the square root of 16, square root of 16 is 4 because 4 squared is 16, just like the square root of 36 is 6 because 6 squared is 36. So the base is the value of this radical. All right, now let's also review this idea. Square root of, let's say 72. Square root of 72. Okay, now these two, remember, these two are perfect squares. So your perfect squares are, your perfect squares are 1, 4, the next one is 9. And remember how to get those perfect squares. You take your whole numbers, and you square them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so that's your next one. 5 squared is 25, 6 squared is 36, 7 squared is 49, and only have room for one more, but there are an infinite number of these. 8 squared is 64, and so on. Okay? So there are an infinite number of these, but these are your perfect squares. Okay, now 16 and 36 are perfect squares. So the square root of 16 is going to be a nice whole number. Square root of 36 is a perfect square. 36 is a perfect square. So the square root of 36 is a nice whole number, 6. Now 72 is not a perfect square. There is no whole number times itself that's 72. But remember in a previous lesson, what we did was we looked for the largest perfect square that goes into 72. Now there are several perfect squares that go into 72, like 1, 4, 9, and then 36. But we use the largest. The largest is going to be 36. So we're going to write this as the square root of 36 times 2. And then remember we wrote this as 2 as a product of two radicals. So we can write this as the square root of 36 times the square root of 2. And then the square root of 36, remember 36 is a perfect square. The square root of 36 is 6. So I get 6 square root of 2. Okay? Let's write this as 1, 2, 3, 4. All right, and then also the square root of 80. Let's review that from a previous lesson. Well, square root of 80, there are several perfect squares that go into 80. If you're not sure how to get the largest, what I would do is just think about, well, what is a perfect square that goes in 80 besides 1? Well, 4 goes in 80. So let's think about that. So 80 rather, is 4 times 20. And notice this 20 right here. Another 4 goes into 20. Another factor of 4 goes into 20. So there are two factors of 4 that go into 80. And then 4 times 4 is 16. So it's going to turn out that and then 5 also is prime. And it's going to turn out that 16 is going to be the largest perfect square. So that's the way I would do this. So I get the square root of 16 times 5. And again, breaking it down like we did here. And you don't have to. You can think of the square root of 16 as 4. But if you need to rewrite it, rewrite it. And so the square root of 16 is 4, so I get 4 square root of 5. Right, number 5. Let's suppose we had 5 times the square root of 24. Well, again, 24 is not a perfect square, but a perfect square that goes into 24, the largest is 4. So I can write this as 5 times the square root of 4 times 6. And then rewriting this radical as a product of two radicals, I get 5 times the square root of 4 times the square root of 6. And then the square root of 4 is 2, so I get 5 times 2 square root of 6. And then 5 times 2 is 10. So I get 10 square root of 6. All right, number 6, I have the square root of 9 over 144. Well, just like I can rewrite the product, the square root of a product as a product of two square roots, I can do the same thing here. I can write the square root of a quotient as the square root of the numerator divided by the square root of the denominator. And the square root of 9 is 3. 9 is a perfect square. And the square root of 144 is a perfect square, so the square root of 144 is 12. And then I can reduce this. So that's going to be 1/4. Okay? All right. Now, let's think about number 7 here. So we have the square root of y to the 8th. Square root of y to the 8th. Now, all we're dealing with here in this section right here, all we're dealing with for this course, part 1, is just square roots. Now, I want you to notice that in this, up until this point, in a previous lesson, when you dealt with the square root of a variable raised to a power, you remember that power was even. Now, in a little while, we're going to see where that power could be odd. But up until this point, this power was even, and so our answer turned out to be a nice answer. But this is what we did to get it. We asked ourselves, just like we did this, the square root of 16. Square root of 16 means square root of 16 is 4 because what number times itself is 16? Well, 4 times itself is 16. What number times itself is 36? Square root of 36 means what number times itself is 36? Well, 6 times itself is 36. That's how we got 6. Over here, let's think of the same way. So the square root of y to the 8th is equal to what? So what we're asking ourselves is what times itself twice is y to the 8th? And these two things I put in the parentheses have to be the same thing. So I want you to think about this. Y to the 4th times y to the 4th is y to the 8th. Because remember, one of our properties, the product rule, says that when you multiply like bases, you add exponents. All right. So the answer here would be y to the 4th. Now remember the shortcut, and we're going to talk about this in a little while. But the shortcut, what we did in the previous lesson, where we said 8 divided by 2 is 4. But mathematically, in terms of conceptualization, this is how we really got y to the 4th. This is a shortcut which normally most people don't understand. So y to the 8th, the square root of y to the 8th is y to the 4th because y to the 4th times itself is y to the 8th. Just like this. If you do it, let's say number 8, square root of y to the 20th. Square root of y to the 20th, so what times itself twice is y to the 20th? Well, you're supposed to say y to the 10th, because y to the 10th times y to the 10th, 10 plus 10 is 20. When you multiply like bases, you add those exponents. So you get y to the 10th power. Remember, the shortcut is to say 20 divided by 2 is 10. Now again, all this applies from a previous lesson, because all we dealt with in a previous lesson, when we dealt with square roots, was the exponent here being even. Okay, now let's talk about that same thing here, but from a previous lesson. Okay, so recall that when we have, let's say, a to the 1 over n. A to the 1 over n. Remember, a to the 1 over n, when we dealt with rational exponents, we can write this as a radical. So we can write this as the nth root of a. Okay? So we can write this as the nth root of a. So we can go from an expression written in rational exponent to a radical, or we can go from a radical to an expression written with a rational exponent. So for example, let's see, I'm going to do cube root here. the cube root of x is the same thing as x to the 1/3. All right, so notice that this right here, this exponent right here is 1. So when you rewrite a radical as an expression involving a fraction as the exponent, your index becomes the denominator, and this exponent here is the numerator. So in terms of number 7, I'm going to write this as number 9 here. If we go back to the square root of y to the 8th, based on rewriting this in terms of an exponent involving a fraction, so in terms of rational exponents, this become y to the, your exponent becomes the numerator, and the index, which is 2, becomes the denominator, and so you get y to the 4th. And so that's why we said 8 divided by 2, only because the denominator is 2. So make sure you understand why we say 8 divided by 2. Based on a previous lesson, we can always write we can always go from radical notation to exponential notation. Number 10, suppose you had the square root of y to the 30th power. Well, the shortcut, remember, is 30 divided by 2, so you get y to the 15th, but here's y. So we get y to the exponent here because it's the numerator, and the index is the denominator, and so 30 divided by 2 is 15. So that's going to help us in a little while. Okay, now here's where it's going to help us, in number 11. All right, we have the square root of y to the 9th. Now we get into a situation where the exponent is no longer even, it's odd. So what you want to think about is this. I want to rewrite y to the 9th as a product of y twice. So y to a power times y to a power. Okay? So you can see I'm going to talk about this, we'll go through this. So what is the largest number less than 9 that 2 will divide into evenly? Well, the answer is 8. 8 is the largest. 8 is the largest number less than 9 that 2 will go into evenly. So in other words, I can write this as y to the 8th times y, because 8 plus 1 is 9. And so now I can write this as the square product of two radicals. So the square root of y to the 8th times the square root of y. And now we know that the square root of y to the 8th, since the exponent's even, that is just y to the 4th. So I get y to the 4th times the square root of y. And that's your answer. Okay, so let's look at another simple one just like this. Suppose I had the square root of y to the 15th power. So remember, you're going to ask yourself, this is now odd. If it's even, it's a nice number, just like this. 8 divided by 2 is 4, so I get y to the 4th. Okay, so the best thing to do is to rewrite it like this. So you want to ask yourself, what's the largest number, whole number, less than 15 that 2 goes into? Well, it's 14. So I get the square root of y to the 14th times y. And I want you to notice, just go through this, since this index is 2, and you always write it like this, this is going to be even, and this is going to be a 1. Only because this index is 2. Now, if this index was 3, 4, then that would all change. But we're only dealing with square roots here. So notice this will be even, and this will always be the variable raised to the first power. 14 plus 1 is 15. When you multiply like bases, you add exponents. And now I can write this as the square root of y to the 14th times the square root of y. The square root of y to the 14th is just y to the 7th times the square root of y. Alright? Okay, now let's look at number 13. Okay, so 13. You have the square root of 49, x to the 7th. Okay, first of all, I want you to notice that 49 is a perfect square. Alright, so I'm going to just leave it like this for right now. So I'm going to rewrite this as 49 times, all right, let's think about x is 7. 7's odd, so we're going to rewrite this. X to the 7th, the largest whole number less than 7 that's even is 6. So I can write this as x to the 6 times x. Okay, now I'm going to rewrite. Now remember, square root of 49 is a perfect square, so I'm going to leave it alone. In other words, I'm just going to leave it as square root of 49, square root of x to the 6, square root of x. So rewrite it like this. Mathematically, that's what this right here means. Square root of 49 is 7. Square root of x to the 6 is x to the 3rd power, and then square root of x. And there's your answer. 14. Suppose you had the square root of 25, a to the 4th, b to the 5th. Okay, first of all, notice that 25 is a perfect square. Also notice that this exponent is 4, so I don't have to write the a's like I did this. You're only going to rewrite it. If the exponent is odd. Now, b, the exponent is odd, so notice what's going to happen. So I'm going to rewrite this as square root of 25. Leave 25 alone because 25 is a perfect square. Leave a to the 4th as itself because 4 is even. Now b to the 5th, remember it's odd, so you'll rewrite it. What's the largest whole number less than 5 that's even, that 2 will go into? Remember, 2 goes into even numbers. So it's going to be 4. So you're going to say b to the 4th times b. And now you're going to rewrite this. Now you can skip this step, but you in your mind you're saying this: the square root of 25 times the square root of a to the 4th times the square root of b to the 4th times the square root of b. And then square root of 25 is 5. Square root of a to the 4th is a squared. Square root of b to the 4th is b squared, and then square root of b. That's your answer. All right, 15. You have the square root of 75 x cubed. Square root of 75 x cubed. Now notice this time 75 is not a perfect square, but a perfect square that goes into 75, the largest, is 25. And then notice this is odd. Okay, so we're going to say this. We're going to say square root of 25 times 3 times, all right, now let's think about the largest even number less than 3. So that'll be x squared times x. So now I'm going to rewrite all of this as the product of radicals, product of square roots. So square root of 25 times square root of 3 times square root of x squared times square root of x. Square root of 25 is 5. Okay, and then I'm going to rewrite. What I would do is go to the square roots that I can simplify. All right, so remember what I'm doing is simplify. So square root of 25 I can simplify as 5. Square root of x squared I can simplify as x. And then these two I cannot simplify. I want you to think about this. Square root of 3 times square root of x. Remember when multiplying radicals that have the same index, you can write this as one radical. Just multiply the radicands together. So it'll be the square root of 3x. So I get 5x and the square root of 3x. And there's your answer. All right. So number 16. Suppose I had the square root of, let's say 72 x to the 9th power. So 72 is not a perfect square, but I do know that 36 is the largest that goes into 72. And I know that this is odd, so I got to rewrite this. So I get the square root of 36 times 2 times x to the 8th. Remember, always use the largest even number that's less than what you see here. And then x. All right, so I'm going to rewrite this as the square root of 36 times the square root of 2 times the square root of x to the 8th times the square root of x. And then these are the ones I can simplify. So that becomes 6, and then the square root of x to the 8th is x to the 4th. 8 divided by 2 is 4. And then I'm left with right here the square root of 2 times the square root of x, and the square root of 2 times the square root of x. When you're multiplying radicals and the indexes are the same, then you can multiply the radicands together. And so there'll be just a square root of 2x. square root of 2x. And there's your answer. Okay, number 17. All right, so 17, you have the square root of 8x cubed y to the 4th. Okay, well, 8's not a perfect square, but I do know that 4 goes into 8, so I get 4 times 2. This exponent is 3, so I'm going to have to rewrite it. So I'm going to get x squared times x. Y to the 4th, I'm going to leave it as it is because 4 is even. All right, now I'm going to rewrite this as the product of all these separate square roots. So I get a square root of 4, square root of 2, square root of x squared, square root of x, square root of y to the 4th. All right, now I'm going to underline those I can simplify. So square root of 4 is 2, square root of x squared is x, square root of y to the 4th is y squared, and then I'm left with these two I'm going to combine as one square root, so with the square root of 2x. All right, number 18, you have 3 times the square root of 40, x to the 10th, y to the 6th, z. Okay, so the largest perfect square that goes into 40 is 4, so I'm going to rewrite this as 3, square root of 4 times 10, x to the 10th, I'm going to leave it as it is because 10 is even. Y to the 6th, I'm going to leave it alone because 6 is even. And then z to the first, there's nothing I can do. I can't rewrite this because that's just a 1. Nothing else you can do there. And so I get 3 times the square root of 4 times the square root of 10 times the square root of x to the 10th times the square root of y to the 6th times the square root of z. And then these are what I'm going to underline the ones I can simplify. Square root of 4, square root of x to the 10th, square root of y to the 6th. So I'm going to get 3 times this 2. Okay, this is a 2 now. So 3 times 2 is 6. So I get 6. 3 times 2 is 6. So I get 6. The square root of x to the 10th is x to the 5th. Square root of y to the 6th is y to the 3rd. And then I'm left with these two that I'm going to multiply together. So that's going to be the square root of 10z. So that's your answer. Okay, 19. Suppose we had the square root of 48, x squared, y to the 5th. All right, square root of 48, 16 times 3 is 48. So I'm going to rewrite this as the square root of 16 times 3. X squared I'm going to leave alone because the exponent is even. Y to the 5th I can rewrite as y to the 4th times y. All right, so remember the largest even number that's less than 5. And now I'm going to write this as separate, the product of separate radicals. Square root of 16 times the square root of 3 times the square root of x squared times the square root of y to the 4th times the square root of y. And then when underlying those, I can simplify. So I get 4. Square root of x squared is x. Square root of y to the 4th is y squared. And I'm going to multiply these two together. So it'll be the square root of 3y. And there's your answer. Okay, 19. 20 rather. Okay, 20. You have the square root of 32, a to the 17th power. All right, so again, 16 is the largest perfect square that goes into 32, so we rewrite this as 16 times 2. A to the 17th I can write as a to the 16th times a. And so I get the square root of 16 times the square root of 2 times the square root of a to the 16th power times the square root of a. And then these two I can simplify, so it'll be 4. Square root of 16 is 4. Square root of 8 to the 16th, the 16 divided by 2 is 8 to the 8th. And then these two I can multiply together, so it'll be the square root of 2a. Okay, 21. You have negative square root of 18, x to the 5th, y to the fourth, z. So 18, the largest perfect square that goes in 18 is 9. So I get negative square root of 9. And then x to the fifth, let me write this. Sorry. So it'll be negative square root of 9 times 2. X to the fifth will be x to the fourth times x. Y to the fourth, leave it alone because 4 is even. And then z, there's nothing you can do that because it's just z to the first power. And then rewriting it as a product of all these separate factors, I get negative square root of 9 times the square root of 2 times the square root of x to the fourth times the square root of x times the square root of y to the fourth times the square root of z. And then underlining those, I can simplify. So those three factors I can simplify. So that'll be negative 3, square root of 9 is 3. Square root of x to the fourth is x squared. Square root of y to the fourth is y squared. And then these are the ones here. These are the ones I cannot simplify, so I'm just going to multiply them together. So the square root of 2 times the square root of x times the square root of z is the square root of 2xz. All right, 22, you have negative 2x times the square root of 8, x to the seventh, y to the third. Okay, so I can rewrite the 8 as 4 times 2, so I'm going to get negative 2x times the square root of 4 times 2. X to the seventh will be x to the sixth times x. Y to the third is y to the second power times y. And I'm going to rewrite this as separate square roots. So I get negative 2x times the square root of 4 times the square root of 2 times the square root of x to the sixth times the square root of x times the square root of y squared times the square root of y. And I'm going to underline those I can simplify. So I get negative 2x times this square root of 4 is 2. Square root of x to the 6 is x cubed. 6 divided by 2 is 3. And the square root of y squared is y. Times the square root of, now I'm going to circle the square roots I could not simplify, but I'm going to write it as 1. So the square root of 2 times the square root of x times the square root of y is the square root of 2xy. Now, go ahead and simplify this part here. A negative 2 times a 2 is a negative 4. X times x cubed, remember you multiply bases, you add exponents, is x to the fourth, and then it leaves us with y. So this part here, this part right here, is negative 4 x to the fourth y times the square root of 2xy. Alright, and that was the end of that section, so hopefully you understand this part. It is not that difficult. Just go back over the video and make sure you understand how we get each of these little parts. It does help if you follow this step. It does help. Okay.